Welcome. In this video, we are going to show that the EMF that's induced is external magnetic field B times length of conductor L times the velocity of the conductor times the sine of theta when the magnetic field vector and the velocity vector are not parallel. So this is our typical setup where everything is perpendicular. We call that mutually perpendicular. Okay, and so we have B into the page. We have a conductor moving to the right. It has length L, and the amount it moves is delta X. This gives us a change in area of L times delta X, and the velocity we know is delta X over delta T. Okay, so let's turn this on end. And so let's say we have the conductor with current into the page. Let's say it moves off in this direction instead of perpendicular, so instead of directly to the right. So here it is at some later time. Okay, so if we're looking at this and the current is into the page, that means the magnetic field is down the page. So we're looking at this on end from the bottom edge. Okay, and so the velocity is going to be parallel like this, and we have angle theta here. This makes, the way this moves, it makes an area that has a normal like so. Okay, so our change in flux is going to be magnetic field times the area of the loop times the cosine of theta plus 90. We need the cosine of the angle between the field B and the normal. So if we draw that over here, we've got B going straight down the page. We've got V going off at an angle like this at theta to the magnetic field B. And then we've got the normal, which is perpendicular to B. So that's why we have the cosine of theta plus 90. Okay? And so we can, at the start, we will have no area enclosed, so we'll have a minus 0. At the end, we'll have the B times the A times the cosine theta plus 90. Okay, we need the trig identity. So we know the cosine of theta plus 90 is going to be the cosine of theta times the cosine of 90 minus the sine of theta times the sine of 90. Okay, the cosine of 90 is 0. The sine of 90 is 1. So we have minus sine theta. Okay, so we can substitute into our change in flux. We have B. The area is L times delta X. And then we have a cosine of minus sine theta. So our change in flux is minus BL delta X sine theta. Okay, induced EMF is minus N times the time rate of change of flux. Okay, so we have minus N times minus BL delta X sine theta. All of that's over delta T. And we know that the velocity is delta X over delta T. Okay, so we have a minus minus for a plus. So we're going to have an N. We have B. We have L. Delta X over delta T is V. And then we have sine theta. And that was what we needed to show. I hope you found this helpful and informative. Thank you for watching. I'll see you in the next one.